Kia ora chemists, welcome back for part 2 of our Lewis diagrams. This time we'll be talking about the expanded octet rule, which is what we move on to in level 3. So at level 3, when we talk about Lewis diagrams, we'll be getting into some slightly more complex shapes that we'll move on to in the lessons to follow. But to start, we're just going to talk about the expanded octet rule. So an expanded octet refers to the cases where our central atoms are in fact able to hold more than 8 electrons. Previously, we only talked about the octet rule, which says central atoms must have 8 electrons around them. However, with the expanded octet, there is an exception to that, and we can find molecules with more than 8 surrounding the central atom. So an example of this that I've pulled out is phosphorus pentachloride. As you can see, around the central phosphorus atom, it's breaching that octet rule, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons surrounding the central atom. So this is all to do with the expanded octet rule, and so let's have a look at how this works. So let's start by counting the valence electrons that we have in phosphorus pentachloride. So if you have a look at your periodic table, we'll see that the P atom has 1, 2, 3, 4, 5 valence electrons, and our chlorine atom has 1, 2, 3, 4, 5, 6, 7 valence electrons. Of course, we have 5 of them, so that'll give us a total of 40 valence electrons. Now, if we start with the chlorine, we're going to draw out this electron configuration diagram that we're familiar with from the previous lessons with Lindis. And we're going to draw out the valence electrons. So this is our configuration of the valence electrons in chlorine. If you go back, you can see that's 3s2, 3p5. And we're going to draw them out. So there are our 3s2 electrons, and then 1, 2, 3, 4, 5, 3p electrons. As you can see, we have one unpaired electron. So this electron is the one that's going to form a covalent bond with our central atom. Now, if we have a look at phosphorus and we draw out the valence electrons in the electron configuration diagram, we can see it has 3s2, 3p3, and we have 3 unpaired electrons. So we might expect to have 3 covalent bonds. However, as you can see in the diagram, we actually end up with 5. So why does this happen? In the phosphorus configuration, we have these 5 empty 3d orbitals. Now what we can do is we can promote one of these paired electrons up to the 3d orbitals, and that looks like this. So by promoting that 3s electron up to the 3d orbital, we suddenly have these 5 single unpaired electrons, which can now form the 5 pairs with our 5 chlorine atoms. And I'll just show you that again there. So we start with our 3s2, 3p3 configuration, and we promote one of these paired electrons up to the 3d orbitals. So that's going to be a higher energy state. So this would be the ground state, and then we go up to this higher energy state with 5 unpaired electrons. So if we look to put the diagram together, we've got the one phosphorus atom, which has the 5 unpaired electrons that we saw here, and we have the 5 chlorine atoms, which each have that 1 unpaired electron, which we saw back here. 5 chlorine atoms with 1 unpaired electron. So if we put it all together, we have our phosphorus atom with 5 unpaired, and each of these unpaired electrons is going to pair with 1 of these chlorine atoms. So if we do our count and check, phosphorus has its 5 valence electrons, chlorine has its 7 valence electrons. This was from the start, and now we have 40 valence. We have 40 valence electrons that we're dealing with. So why don't we count and check our Lewis diagram to make sure it still all adds up. We have around the phosphorus atom, we have 1, 2, 3, 4, 5 covalent bonds. So that's 10 electrons. And in each chlorine atom, we have 3 lone pairs, adding to 6 electrons. And we have 1, 2, 3, 4, 5 of those, meaning we have 30 lone pairs, 15 lone pairs with 30 electrons each. We have the 5 covalent bonds with 10 each. We add them together and we get 40 electrons. And that's good because the 40 electrons matches the 40 valence electrons that we started with. So I've got a few questions for you to complete. So if you take these down and have a go at them, and thank you very much for listening.